This lesson is going to talk about reflections. Reflections are still in the category of an isometry because they do not change the size or shape from the pre-image to the image. However, the orientation of my coordinate points will be different on the image because I am flipping or reflecting or creating this mirror image when I am going from my pre-image to the image. So if you look at this example, the way that my orientation is going to change is based on this center line here. This center line is my line of reflection. So based off of this line, I'm going to look at points A, B, and C and figure out how they would be oriented when I flip this top triangle over this center line. You'll notice that the relationship between each of my points is going to maintain the same distance from this line of reflection. So if you're looking here at point A, when I reflect over the line of reflection, this coordinate point down here on the bottom is going to end up as A prime. I'm going to look at B the same way. It's going to maintain the same distance away from that line of reflection. So this corner point here would become B prime, which would leave C prime as being my point on the bottom. And if you were to find the distance between this top point of C and the line of reflection, it would be the same distance down to C prime. The first reflection we're going to do together is a reflection over the x-axis. I've already labeled my pre-image points of A, B, C, and D. And when I go through and do my reflection, what I need to do is maintain the same distance away from the line of reflection. So if I look at point C, it's currently 2 spaces away from the line of reflection. When I mirror that to the opposite side of the line of reflection, I need to maintain a 2-space distance or a 2-unit distance, which would put me right here. I'm going to do point D next. Still, this is 2 spaces away from the line of reflection, so I'm going to be 2 spaces away from the line of reflection on the opposite side, which would put me at 1, -2. And I'm going to do the same thing with point B and point C. So point B prime is going to land down here. A prime will land over here. I'm going to come back in and label these so that you can see where my prime notation has oriented itself. And my new rectangle is going to live in quadrant 4. If you look at the coordinate points for this, my A prime has now landed at 1, -6. B prime has landed at 8, -6. C prime has landed at 8, -2. And D prime has landed at 1, -2. Ultimately, in this case, because I am talking about the x-axis, I can write this as a rule. My rules are always going to start with x, y. And if you notice the relationship between my pre-image points and my image points, each of these x values here are exactly the same as what they were to start. My y values are almost the same, however, they've all become negative because I have now switched to quadrant 4, where all of my y values are negative. So if I'm writing my rule, x has maintained the same number and the same sign. whereas y has become negative. So this rule here, xy going to x negative y, is the rule that I can use if I'm reflecting over the x-axis. I'm going to start off with this reflection using the same rectangle as we did on the previous example. However, now I'm changing my line of reflection to the y-axis. It's going to be the same scenario as we had before. A, B, C, and D are in the same pre-image location. However, now I'm going to be reflecting from quadrant 1 into quadrant 2. So if you'll notice, point A and point D are both 1 unit away from my line of reflection. So point A and point D are going to maintain that distance when I do my reflection. So this is going to be A prime. This point will be D prime. Going to do the same thing with B and with C. So C prime will land down here. B prime will land up here. I'm going to come back in and label those. And here is my new rectangle. If I'm looking at the coordinate points, A prime is now at -1, 6. B prime is now at -8, 6. C prime is at -8, 2. And D prime is at -1, 2. Similar situation to an x-axis reflection. However, in this case, my y values have maintained the same value and the same sign, but my x values are now the ones that have become negative. So I'm going to write that this rule is xy being mapped onto -x, positive y. Now we're changing our line of reflection a little bit. I'm no longer using one of the x or y axes. I've changed it to x equals -2. If I'm talking about a line that is one specific x value, that is a vertical line. So in this case, my line of reflection is a vertical line where all values of x are equal to -2. So if I'm looking at my same original rectangle with A, B, C, and D, when I do my reflection, now I need to look at the distance from this vertical line that I've highlighted in red. So if I'm looking at A, it is currently 3 spaces away. So when I reflect it, A needs to be 3 spaces away again, which would put us here. And I'm going to label that as A prime. I'm going to switch and do point D now, because point D is also 3 spaces away. So I need to reflect D 3 spaces away on the opposite side of this line. My graph isn't large enough to put point B and point C prime on the coordinate plane, but if you were going to do that, I am 10 units away from this vertical line. So I would need to be 10 units away, which is going to put me somewhere in this region. And when I connect those dots, we'll get a general idea of where point B prime and C prime would land. In this case, I'm not going to write a rule because using x equals -2 as my line of reflection is not going to be pretty. So for us, our rules are going to be off of the x-axis reflection or the y-axis reflection. If you're asked to do a reflection over a line that's not one of the axes, but is a vertical or horizontal line with a specific x value or y value, we're not going to use a rule. We're just going to do our reflection like we've done on this slide here.